Hello and welcome to a screencast about determining whether a relationship is a function or not. Got a definition here. It says a function is a process that may be applied to a collection of input values. Input's going to be an important word for us. To produce a corresponding collection of output values, another important word, in such a way that the process produces one and only one output value for any single input value. All right, let's look at kind of just a generic case here. Is the relationship between people and birthdays a function? And I'm going to say it depends. So looking back here at our inputs and our outputs, so let's say our input is the person, because that's how I would read it, right? Person and then birthday, but it doesn't have to be. So your output is your birthday. All right, so if our input is the person, then does that give us exactly one and only one output? So does every person have exactly one birthday? I would say yes. But what happens if it went the other direction? So what if your input was a birthday and the output was a person? Is the answer still yes? And I would have to say no. Because birthday, okay, so let's pick a date. How about January 1st, just to make it easy? Can you think of anybody or multiple people that you know that has a birthday on January 1st? And you've got a limited number of people, but think about everybody. There's definitely more than one person that has a birthday on January 1st. So I'm going to say no to that one. So really the inputs and the outputs do matter, which order it goes in. All right, the table. Is the relationship between X and Y that is given in the following table, where we attempt to view Y as depending on X, a function? Okay, so this right here, Y depending on X, tells us that X is our input and Y is our output. And again, you would typically put them in the order on the table, but just know that's not always necessarily going to be the case. Okay, so I would think about this then. So I'm looking at my inputs and I see a 1 here and I see a 1 here. So do those ones have the same output? Oh, actually they do, right? As it turns out, they both have an output of 6. So, okay, that doesn't really make any difference. But now I'm going to look at my 3s. Oh, I see a 3 here and I see a 3 here. 3 goes to 7 and 3 goes to 8. So we can say, no, this is not a function. Because 3 goes to 8 and 3 goes to 7. Now, if one of those particular outputs was not included for some reason in this table, then we could say yes. But for the table we're given, it's a no. All right, then graphs. Another way we can look at functions, or to see if relations are functions. So here, is the relationship between X and Y that's given in each graph below, where we attempt to view Y as depending on X. Okay, so again, this is X and this is Y. These are our outputs. Oopsie. And these are our inputs. So can we say this is a function? I don't know. Pick an input. Pick something that's along our x-axis here and see how many y's pop out. Okay, so I'm just going to pick 0 just because I like 0. It's nice and easy right in the middle. It's on an axis too, which makes it nice. So if 0 is my input, what are my different outputs? Is there 1 or is there more than 1? Well, okay, here's 1. Y equals -1. Here's 1. Y equals +1. And, oh, this one had 3. Y equals 3. So this is a hard no, not a function. Okay. Next graph over here on the right. So this is an interesting looking graph. So we've got a line, but then we've got something that happens here at x equals 2. So this little open circle right here means that there's a break in the graph, right? So if x is 2, I'm going to not have a y value here, but I am going to have a y value here. Okay, so do you guys agree that at x equals 2 is really the only kind of weirdish spot that we've got going on? So let's think about this. So if x equals 2, what do I have for my output? I only have y equals 3. Okay, because again, this whole means it's not defined there, so we're not going to include that. So we could say, yes, it is a function. Okay, this leads us to our last idea here for functions, and this is something might be familiar to you from a previous algebra class, the vertical line test. A graph in the plane represents a function if and only if every vertical line intersects the graph at most once. Okay, so let's look back at our graphs that we had here. Let me switch colors. So if I make a vertical line in this z graph, and again, doesn't matter for this particular graph where you make it, let's say I made it, how about here? And that's kind of a vertical line. Oops, ignore my little mark there. How many times does it cross the graph? Does it cross it exactly once? No, it crosses it 3 times. Okay, but what about our graph over here on the right? Again, you know, you can make vertical lines. Yeah, that's nice. Again, our only really interesting spot here is at x equals 2. If I make a vertical line there, you may think, oh, it hits the graph twice, but no, remember this point here is not included. So that's not, it still is a function, right? It only hits the graph once because that's the only point that is included. Okay. All right, well, I hope this helps you with this particular concept, and thank you for watching.